All right, we are in section 6.1 where we're going to talk about ratios, proportions, and geometric mean. To start, we'll talk about ratios. Definition of ratios is comparing two numbers or quantities using division. If you look here, these are the three ways that we can write a ratio. The first one was you can write it as a fraction, or you could say you could write it as comparing something to something, and then this and this basically mean the same thing. So it's like you comparing it from A to B, and it's the ratio from A to B. So what we have to start with, we have some examples to take a look at. First thing we want to do is we're going to try to simplify the ratio. So when they're asking to simplify the ratio, that means basically they want you to take out the unit measure. In order to take out the unit measure, um, the measure on the top and the bottom of the fraction must be the same. So if you look in example A, it says 20 inches to 5 inches. So you can rewrite this as a fraction, 20 inches over 5 inches. Okay, since I got inches on the top and inches on the bottom, that can cancel. And 20 divided by 5 is 4. So my simplified ratio for this particular example is 4 to 1. Okay, what's different in example B is I got pounds on the top and ounces on the bottom. What we have to do in order to simplify this ratio is we have to get them both the same. And the easiest way to do that is to um, do some unit analysis when to one of the values in either the numerator and denominator. I look at that, I see pounds, I see ounces. Ounces is the least of the measure of the two values, and that is what we're going to try to make both numerator and denominator become, because from previous lessons, or at least you could look it up on Google, 16 ounces equal 1 pound. Okay, so I'm going to convert the 3 pounds into, if I take 16 times it by 3, 3 pounds is the same as 48 ounces. And then I got the 10 ounces on the bottom. Ounces cancel. And if I take 48 divided by 10 and I simplify that fraction, it becomes the ratio of 24, excuse me, over 5. Same thing for C. I got gallons on the top. I got quarts on the bottom. Quarts is the smaller of the unit measures, so I know that 4 quarts equal a gallon. And so 4 times 4 is 16. So instead of writing 4 gallons, I got 16 quarts on the top. And it's going to be over 36 quarts. So they're the same. The units cancel. And when I could simplify it, it becomes 4 over 9. And then finally with D, I got 80 centimeters to 2 meters. Centimeters is the smaller of the two, and I can get 100 centimeters in 1 meter. So that means I can rewrite this as 80 centimeters on the top over 200 centimeters on the bottom. 200 centimeters is equivalent to 2 meters. The centimeters cancel, and I can simplify this to 2/5. Okay, so looking at some more ratios to simplify, these two examples here, I got example A and example B here. They want us to find the ratio of the width to the length of the rectangle. It says also use, and then they also want us to use the number line to find the ratios of distances. So this is where this example comes in. But the first part, I'm going to find the ratio of the lengths of the rectangle. All right, same rules apply. The width is usually the smallest length, so that goes on top. So 3 inches is my width in this case, and 15 inches is my length. They both have the same measure with inches, so that can be canceled. And then 3 divided by 15 can be simplified as 1 out of 5. Looking at example B, I have the smaller length appears to be the 320 centimeters over the 10 meters. Okay, now this is a situation kind of like we had in the previous examples where we have different unit measures. All right, so what we have to do is we have to change the larger one. So centimeters is a smaller unit than meters, and we found out from the top that 100 centimeters equals 1 meter. So that means I can rewrite this ratio as 320 centimeters over, which means I can take 10 and multiply it by 100, which then gives me 1,000 centimeters. The centimeters cancel, and 320 over 1,000 can be reduced to 8 over 25. Okay. Looking at the number line, what they're going to do is they give us distances here. I got 3 examples to choose from. They want us to find the ratio of the distances. So the first one is the distance from A to D over the distance from B to C. So I go to look at A, which is right here, and D, which is over here somewhere. And what we're going to do, I want to find the distance. So this is at -9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the distance from A to D is 13. BC is going to be 1, 2, 3, 4, 5, 6. Is 13 over 6. And I can't simplify that anymore, so that is the ratio. Going to the next one, I got CD. CD is 1, 2, 3, 4, so it's 4 units away. And DE is 1, 2, 3, 4 units away, so my ratio is 1 to 1. And then finally, EF is 1, 2 units away, and CD is 1, 2, 3, 4. So the ratio to these two values is 1 to 2. Okay. The next thing we're going to take a look at is proportions. Proportions is an equation that states 2 equal ratios. So here we have 1/2, and then it's equal to 3/6. They're both equivalent ratios. How we can determine whether ratios are equal or not is by determining what is called the cross products. So here, if you look here, I took B and I multiply it by C, which is right here, and I got A multiplying it by D. So if I were to take these ones here, 2 times 3 is 6, and 1 times 6 is also 6. So since they equal each other, we know that they are proportional. So when we want to solve a proportion, such as these examples here, we're just going to cross multiply. So I cross multiply here, I cross multiply here. I get 10x on one side, and it's set equal to 5 times 16, which gives me 80. And then I divide both sides by 10, so that means x equals 8. Okay. Looking at example B over here, I get to rewrite this as 3y equals, and now since I have addition in this denominator here, actually it's going to look like the distributive property, so it's going to be 2, and then I'm going to times it by the quantity of y plus 1, and then I'm going to distribute the 2. So then 3y is on the left hand side, and I get 2y plus 2. I'm going to subtract 2y to both sides, and I get y equals 2. Okay. Same thing goes here for example C. I get 7y equals 14 times it by y minus 3. So 7y is set equal to 14y minus 14 times 3 equals, so it's minus 42. I'm going to subtract 14y to both sides, so I get negative 7y equals a negative 42. And when I divide negative 7 to both sides, I get a positive 6 for y. Okay. The next thing that we're going to take a look at is geometric mean. Definition of geometric mean is two positive numbers, a and b, is the positive number x that satisfies this equation. A over x equals x over b. So essentially, when we do the cross product of this one, here I get x times x, which is x squared, and a times b, which is ab. And in order to solve for x, we have to take the square root of both sides. So essentially, x equals the square root of a times b. So these examples here, they want us to find the geometric mean. When we look for the geometric mean, we got some numbers here. So this means that like this is a and this is b. A and B and A and B. All right, if you want to pull it in the proportion, that's fine. But since they already told us that essentially this is the value we want to solve for, so what we're going to say is x equals the square root of 12 times 27. All right, so 12 times 27 gives me x equals the square root of, oh shoot, x equals the square root of 324, and the square root of 324 is 18, so x equals 18. All right. I go over here, that means x is going to equal the square root of 18 times 54, and I get x equals the square root of 972. If I take the square root of that solution, I get a decimal for that. So what I have to do is, you could say that x would equal roughly 31.18, or if you wanted to be more precise about this, so let's see here. I see that, well, first off, I can say that x equals the square root of, I can say 972 is what, 81 multiplied by 12. And I know that the square root of 81 is 9, so I can say that x equals 9 times the square root of 12. But 12, I can say that x would equal 9 times 4 times 3, and the square root of 4 is 2. So I can say that x would equal 18 times the square root of 3. Okay. Finally, we got 16 and 18, so that means I take x and it's going to equal the square root of 16 times 18. X is going to equal the square root of 16 times 18, which gives me 288. And the square root of 288 is, again, it's roughly 16.97, but let's take a look here. 288 goes into, whoops. Well, I know that for certain 288 can be rewritten as 9 times 32, and I know that the square root of 9 is 3, so x equals 3 on the outside times by the square root of, I can break down 32 by saying 16 times 2, and the square root of 16 is 4, so x actually could equal what? 12 times it by the square root of 2. So these are your, that's your approximate answer, and that is your more precise answer. Finally, it says you want to find a ratio of the measurements of two supplemental angles. The ratio is 4 to 5. All right, they want us to find the measure of the angles. Okay, so essentially what I did was excuse me, I wrote a proportion. So I knew that the angles was going to be 4 out of 5, and they also told us that the two angles were supplementary angles. That means they add up to 180 degrees. So what I'm going to do is I don't know what the values are, but I can say that one value is x, and it's going to be over, and the other value is going to be 180 minus x. So essentially we're just going to do the cross product, so I get 5x equals 4 times by the quantity of 180 minus x. I distribute that, I get 5x equals 720 minus 4x. I'm going to add 4x to both sides, so I get 9x equals 720, and dividing both sides by 9x equals 80. So one angle is 80 degrees, and then 180 minus 80 is going to be 100 degrees. And if you plug those into a proportion, it would in fact be the ratio of 4 to 5. Okay, and then the final example in this section is they want us to find the ratio of the two sides for the given, or for the triangle given. It says solve for the variable. So it's telling us the ratio from AB to BC is 5 and 9. So again, I'm just going to write that down. I'm going to set that equal to, so A to B is right here, so that's 15, so that goes up on top, over B to C, which is 5R plus 2. They want us to solve for R. So I'm just going to do the cross products. First off, 9 times 15 gives me 135, and it's set equal to 5 times by the quantity of 5R plus 2. I get 135. I distribute, it's going to be 25R plus 10. I subtract 10 to both sides, so I get 125 equals 25R. And dividing 25 to both sides, R equals 5. And that is being able to solve for ratios, proportions, and geometric means. Hope this helps. Until next time.